So this second method that we talk about, the polynomial division, is synthetic division, where you can limit yourself to divide a polynomial only with the linear factor or linear denominator. Now what I mean to say is, let us say when I have to divide x squared plus 3x minus 5 with x plus 2, I can't use synthetic division. Obviously, what is synthetic division and how do we do it? It'll become clear once I explain it to you. But right now, when I'm dividing this polynomial, let's say when I'm dividing by x squared plus 2, it won't work. Synthetic division won't work. In that case, you always try to do using the long division method. Synthetic division only works where you can see like a linear factor. Now, what's the standard procedure in this? So the standard procedure is that first we make like a half rectangle. And of course, this can be different. You don't even draw it. It's okay. It's just my own way. Write down the coefficients of all the terms in descending order. So let's say if I have got x squared plus 3x minus 5, I'm going to write down 1, 3, and minus 5. Now you can ask a question where if some term is missing, let's say I had, there was no x term here. So in that case, here will be 0. So this is the coefficient of leading term, and this goes on with falling values. I will do two sums parallelly so you can understand. Let's say if I'm dividing x cubed plus 5, x plus 3 with, let's say, x minus 1. So now in this case, what we basically do is we take, let's say 1. You can say there's no x squared term. So we take 0x squared. So you don't need to write down x squared and all. So 1, 0, and then you get is basically next is x term, and then last is the constant term. And what is the other step? What is the other thing that you use? Now, what we do is we take like, this is the factor by which you're dividing. So we take actually here, what we take is the root of this factor. So it's like x plus 2, if I equate to 0, I get x is negative 2. Similarly, if I equate x minus 1 to 0, I get is x is 1. So just divide with now, I'm not going to use any x's. I'm not going to use any variables. So I'm just going to use these numbers. So you can see the two sums I'm running parallel. So here, I'm just going to draw another line. Now, what is the first step? Now, when you start the division, the first step that we get is actually carrying down the first number as it is. So the 1 that you see here comes down as it is. So here you see that there is 1 here, it will come down as it is. So first number, you bring down as it is. Don't need to do anything. After this, your procedure starts. So now you multiply these two numbers. So 1 times negative 2 is negative 2. So you're going to write down right below the next number, so negative 2. Now you add these two numbers. So 3 and negative 2, if I add, I get 1. Once again, you do the same thing. 1 if I multiply with negative 2 now. So if I multiply with negative 2, I get is negative 2 here. So write down as it is. Now if I add these two, what I get is negative 7. And so this number that you get is actually the remainder. Last number is the remainder. And these two that you see, now this is the constant term and this is the coefficient of x. So if I would have long divided this, which you probably can try and do this, you would see that if my x plus 2 is a divider, the quotient will be x plus 1. So just this is the constant number, this is the coefficient x. So x plus 1 is the quotient. And whatever you do, you'll see that the remainder that comes is negative 7. So that's how you do the synthetic division for the first case. Now let us do for the second one also so that we become confident. Now 1 times 1 will be 1. 0 plus 1, now add these two. So 0 plus 1 is as it is, 1. Now again you multiply 1 with 1, which is again 1. Now 1, if I add these two, I get 6. Now multiply 6 times 1, it is 6 again. So what you get is, this is 9. So in this case that you see, the remainder that you're getting is actually 9. And the quotient that you're getting is x squared plus x plus 6. So you can try the long division and you will notice that you are getting this as x cubed plus 5x plus 3. When I divide a long divide with x minus 1, I'll get quotient as x squared plus x plus 6, and the remainder will be 9. And that's where we stop this division. I repeat again the structure. You're going to write down the quotient, the coefficients, and you take the first number as it is, multiply, and right below the next one, add these two, multiply the resulting number with the negative 2, this whatever is your divider factor, and then you put it down below the next one. So this is like a series of the operations that you do. This kind of division I would recommend where you see that there is a time constraint in your assessment, and I highly discourage sometimes to use this method in the kind of problems that I'm going to cover next. But this is like good when you have something like this and you wish to do save some time. So the little confusing part that comes is when I'm dividing with a number. It's not confusing, but we need to set a trend for those kind of questions as well. So let's say if I'm dividing uh, a polynomial 2x squared plus 3x minus 1 with, let's say, 2x minus 1. And according to my long division, if I do the long division here, my first coefficient will be x, and you'll get 2x squared minus x here, and this become minus, this become plus. So 3x plus x will become 4x and minus 1. And next one will be 2 here. So it'll become 2x minus 2, 4x minus 2. And if you subtract, you get the remainder as positive 1. Now let's do the same thing when I'm doing with the synthetic division. Let's see what result we get. So when I'm doing synthetic division, I'm going to first write down these coefficients. So 2, 3, and negative 1. And I'm going to obviously take here as half because 2x minus 1 is going to be 0. So x is half I get. So that comes here. Now, the first number you bring down as it is. So you get 2. Now 2 times half that you get is nothing but 1. And 3 plus 1 is 4. Now 4 times half is 2, so that comes out here, and your remainder is 1. The remainder, there is no problem. The remainder as such, there is no problem. But the problem comes is when you look at the quotient of this and the quotient of this. So whenever you're dividing a particular polynomial using synthetic division, you can see that the difference in the quotients, like if I say the quotient is 2x plus 4, now this 2x plus 4 is actually completely wrong because if I divide, let's say 2x plus 4 is my quotient, and also if my 2x minus 1 is the divisor. So what happens is that my polynomial px will become ideally quotient times, let's say, which is like divider plus remainder. This is the general structure. Now quotient I'm taking is, let's say, 2x plus 4 that I got, and divider that I had is 2x minus 1, and remainder that we have is 1. Now what you notice here is that the resulting polynomial is not giving me the coefficient x squared same, which I took in the beginning. Here the coefficient x squared is 2, and here the coefficient of x squared you'll get is 4. So actually, where did we go wrong? Now the problem here is that we went wrong because actually we divided with the factor x minus half. So in such cases, like wherever you are dividing with, let us say, a polynomial with ax minus b or ax plus b, at the end, whatever you just get the quotient, just divide that quotient by a. So let's say I got 2x plus 4 as the quotient, and my coefficient of the divisor, like a, the coefficient of x is 2 here. So I'll just divide by 2. Obviously, you can take 2 common and you get x plus 2 here, and this get cancelled and you get x plus 2. So this is actually my quotient. So x plus 2 is actually the quotient that I have got, which is same as the previous one. So what precaution you take when you're dividing by a linear factor with a certain coefficient is just be make sure at the end after doing what you got, just divide by the coefficient of x of the divider. So here the coefficient of x was 2. You just divide the quotient, this quotient by 2, and of course that's my answer. And just to add this up, I'm just gonna give the final evaluation of the polynomial division is basically whenever you're dividing, make sure whenever you're dividing a polynomial px with certain divider dx, and let's say your quotient is qx, and you get certain remainder rx or a constant number, then polynomial px can be written as quotient times divider plus remainder. And this is a way to cross check your answer like how we did in our previous case. Now this form or structure is modified as px over, let's say if I divide both the side by divider dx, what we get is, you will notice that I'll get quotient, because if I isolate these two terms, dx and dx get cancelled, plus remainder over divider. So this becomes one of the important backbone for the functions that we get. So px over dx equals to quotient plus remainder over divider. So whenever you're dividing by polynomial, it can be put into this structure. Now, let us take an example where we are actually writing, suppose if I'm doing x squared plus 2x plus 3, if I'm dividing by x plus 1, x minus 1, let's say. So x squared plus 2x plus 3 when I'm dividing by x minus 1. Here will be x squared minus x. Subtract, this become positive, so it become 3x plus 3. And then you take positive 3, so you'll get 3x minus 3. Subtract, this become positive, 3 plus 3, 6. Now, what you notice is that if I have to write down, let's say x squared plus 2x plus 3 over x minus 1, this can be written as quotient, which is x plus 3, plus remainder, which is 6, over divider, which is x minus 1. And if you simplify this, you will notice that you're getting the exact same polynomial. And that's the magic of all these methods, the polynomials. And obviously, this will be very helpful for us when we are working on the rational functions as well.